Let's understand this problem. Here, the task is to find out the waveform of output voltage when the input voltage is some sinusoidal function, and there is one capacitor also, and resistance, and one Zener diode is also there. Now, in the question, it is mentioned that the RC is very large. RC is very large means that is no discharging, no substantial discharging of this capacitor. Means once this capacitor is charged, there is no substantial discharging. Now look at the path from where it can discharge. Okay, it can discharge via this path, this resistance path. Okay, now in the question itself it is mentioned there is no substantial discharging, so we can assume this resistance to be very large. Okay, ideally it should be infinity. Okay, basically there is no discharging happening. Okay, so for the sake of analysis we can simply remove this resistance. Okay, now let's analyze the circuit. Okay, let's assume that this capacitor is initially charged. Let's see how it is going to be charged. Initially no charge is there. Okay, how it is going to be charged? In the positive half cycle, this is reverse bias, so there will be no charging in the positive half cycle. We have to move to the negative half cycle. In the negative half cycle, there is a path for charging of the capacitor. Okay, but this Zener diode is not going to allow the charging till this input voltage reaches 5. Okay, then only charging will happen. Okay, now assume if this Zener diode is not there in the circuit, then this capacitor is going to be charged to maximum voltage, maximum input voltage, that is 10. But this Zener diode is going to drop some voltage when it is in breakdown. It's around 5 volt. Then this capacitor is going to charge to a maximum value of 5 volt only. Okay, so now this capacitor gets charged with 5 volt, with this as positive and this as negative. Okay, now once it is charged, there is no discharging. Okay, because this is the only path for discharging. We assume that this resistance is very high, so there is no substantial discharging. It is mentioned in the question. Okay, now the task is to find out the output voltage. For that, we can simply write a KVL in this loop. Okay, in this loop, so I can write this. Let's say this is plus and this is minus. Okay, so I can write Vs plus Vc, okay, equal to V naught. Okay, now Vc is constant 5, Vs is this Vm sin omega t, it's input voltage. Now this is your V naught. Okay, output voltage means in the output voltage is equal to input voltage plus 5 volt. That's it. Okay, so let's say this is your input voltage plus 5 volt. It is going to shift upward by 5 volt. Okay, so the overall waveform will look like this one. Okay, it is just a shifted version of this waveform by 5 volt. Okay, in the lab also you have done this kind of circuits. I get you have done the clamper circuit. It is nothing but a clamper circuit, but there is you did not connect this Zener diode. Okay, so the entire waveform got shifted by Vm, but here one Zener diode is there, so it is going to be shifted by voltage Vm minus this volt. Okay, here it is 5, so it is going to be shifted by 5 volt only. Okay, so some students have made mistakes in this problem, but overall many students have done correctly. Okay, some students also consider the discharging like this one. No need to consider the discharging, because in the question itself it is mentioned that RC is very large, so there is no substantial discharging. Okay, those who have drawn like this one also, they will get full marks, no problem. Okay, I will consider. Okay, but next time in the exam, if it is mentioned that RC is very large, you can simply ignore the discharging part, and you can analyze like this one. Okay, I have written write down the all analysis. Okay, you can go through it one time. Okay, thank you.